Mr.
Yes, sir.
I already give you the co-host permission, so I believe you can share your files now.
Okay, sir.
Can you please check?
Yes, sir. Yes, sir, I'm able to share now.
Okay, please start your presentation. Sorry for the inconvenience again.
It's okay, sir. So first of all, thank you for giving me this opportunity. My research paper was on the topic, a comparative analysis of machine learning classification algorithms for the detection of breast cancer. I'm the author, Prerna Rai, and my corresponding author, Dr. Jay Saraf. The plan of talk is given as follows. The abstract. Breast cancer is a very common type of cancer, and successful treatment and detection is quite difficult. And breast cancer is a serious disease that is one of the most common leading health issues for women worldwide. And AI-based automation can save time and reduce error. And many machine learning techniques such as logistic regression, KNN, decision trees, and random forest can be used together with data visualization to help us identify the cancer. And in my work, I have used Python as the programming language for the machine learning models and visualization. The visualization and techniques which I used here can create an impact on the cancer diagnosis and decision making. While the all-featured KNN classifier model achieves the best classification, which was around 0.96%, the proposed methods show improvement in accuracy results as well. The introduction. Me being a woman, I understand the severity of this issue of breast cancer, as cancer deaths are one of the most important problems faced by people in developing countries. There are also many ways to prevent the cancer, and that is early detection. But some cancers are still incurable. So it's best that we detect them as early as possible to have a safer treatment which we can have. Successful treatments depend on early detection, and accurate diagnosis can be done using classification methods, AI, and machine learning. So we did a comparative analysis of machine learning classification algorithms to find the best one that will be the most accurate for the detection. We also did literature survey to have a review about the earlier studies made on this topic. It helped us in getting knowledge about what has happened and what we can do. Now, the problem gap and how we are solving it. There are many algorithms that can be used for the detection, but not all of them are going to be precise. And after going through the previous work done on this topic, we have selected 4 classification algorithms for the detection. That is decision tree, KNN, logistic regression, and random forest. And then we did a comparative analysis to find which one will help us find the accurate results. The methodology and data set used. In this study, we used data set from Kegel, which was the breast cancer Wisconsin diagnostic. The data set was generated using digitalized image of a cancer fine needle aspirate. The data was cleaned and prepared by removing irrelevant columns from the data set, and a correlation mapping was also performed using heat mapping to determine whether or not there is a relationship between the two variables. We did a heat mapping of the data set to determine the correlation between two variables, since there was a high correlation between mean columns. Then a scatter plot was also performed to get further detailed picture of the correlation between variables. And we used partial least square regression or principal component analysis as well. Then we remapped the data set to check whether there was any high correlation present or not. There was a few in the region of concavity and perimeter points, etc. So we selected, since we cannot select all of them, we selected one and then remap the data set. We used 4 algorithms here: logistic regression, random forest, and decision tree. We use logistic regression because It provides coefficient for each input feature, including their influence on the predicted probability, and the positive coefficient imply a positive association with the positive class, that is the cancer, while negative coefficient imply a negative association. Analyzing these coefficients can provide insight on the important features of breast cancer detection. Random forest. Random forest provides a measure of feature importance, indicating which features are most influential in predicting breast cancer. We can examine these important scores to gain insight into the factors contributing to breast cancer detection. Decision tree. While using training set, we apply decision tree algorithm to create a decision model. The algorithm will automatically determine the most informative features and construct a tree-based structure of decision rules. KNN is a supervised learning technique. In this technique, the label of the data is chosen before predictions are made, and it can be used for clustering and regression. K here is the number that represents the nearest neighbors. The algorithm has no training step to make predictions. The Euclidean distance to the K nearest neighbor is used. This method is used to predict breast cancer in a dataset with classifications such as malignant and benign. The label is assigned based on its proximity to the class labels of its neighbor. The table of results. The comparison and training accuracy was defined by the mathematical formula, which is accuracy is equals to x upon n into 100. Here, x represents the number of instance cases that were classified correctly, and n represents the total number of instance classes. The comparison of the training accuracy table is given here, and the data set was divided into a 70-30 ratio, where 70% was used for training and 30% was used for testing. The performance comparison. Cross-validation techniques compares the performance of each model to a new dataset, often known as test dataset, outside of the sample. Because we are fitting a model to a training dataset, we use cross-validation procedures. Basically, it is a resampling technique used in machine learning and model evaluation to assess how well a model generalizes to unseen data. It helps to estimate model's performance and evaluates its ability to handle new data by stimulating the model's performance on multiple train test splits of available data. It is a great method for
Presenter 3, please turn off your mic, please.
Okay.
Please, Ms. Roy, please continue.
Yeah, sir. Yeah. So it is a great method for testing and evaluating classifier accuracy, since it randomly divides the training set into K subsets, one of which is used for testing and the rest for training. After the performance comparison, the results are given in the table here. Now, according to the table, we can conclude that KNN classifier outperforms the other in terms of accuracy, precision, recall, and F1 score. These data suggest that of the 4 proposed classifiers, the KNN model is the best at determining whether a tumor is benign or malignant. Future scopes. Integrating multiple data sources, where machine learning algorithms can be trained on a variety of data sources, and they will combined, we have the potential to improve the accuracy of breast cancer detection. Personalized treatment recommendations, where algorithm can be used to identify patients who are at a high risk of developing breast cancer, and to personalize treatment recommendation based on their individual risk factors. And early detection, where algorithms can be used to analyze mammogram images and identify early signs of breast cancer. Integration with other healthcare technologies, where algorithms can be integrated with other healthcare technologies such as telemedicine, wearables, and mobile apps to improve the efficiency of the cancer treatment. And predictive modeling, where algorithms can be used to develop predictive methods that can help identify the patient's history and everything for breast cancer. We used a number of references which also helped in our literature survey, which are given here. Thank you.
Thank you, Ms. Roy, for your nice presentation. So any of the participants have any question for Ms. Roy? Any of the participants have any question for Ms. Roy? Ms. Roy, maybe I think they do not have any question, but I have one question for you.
Yes, sir.
So most of the algorithm you use, starting from the logistic regression, then KNN, decision tree. So all of them are based on the machine learning one. So why don't you consider that support vector machine, SVM?
So I wanted to consider support vector machine, but since while I was studying, I was more focused on these 4 algorithms and I had a better knowledge about them. That is why I considered these 4.
These 4. Can I go to your result part, please?
Yes, sir. So this one?
No, the previous one, please. So here KNN accuracy comes 95%, but decision tree come 100%.
Yes, sir.
So it seems like the decision tree is giving better performance. Am I right?
So yes, but it was, yes, sir. So, but it was giving this for the training method, and we just cannot rely on this particular thing. And
yeah, so I understand.
Yes.
Okay. So can you go to the next one, please?
Yes.
No. Next result, like precision recall is there. Thank you. Okay. So here KNN accuracy is 96. Okay. Thank you. Thank you for Mr. Thank you for your nice work.
Okay. Thank you, sir.
Thank you very much. So I believe presenter 3 is here. Presenter 3, paper ID 5261. Mental health analysis on Twitter data. Paper name.
Hello, good morning, sir. Am I audible?
Good morning. Can I have your name, please?
The Saurabh.
Okay, thank you. Mr. Saurabh, I make you the co-host, and you can continue your presentation and check whether you can share the file or not.
Hello, sir. Am I audible? Saurabh, sir,
yeah.
mental health disorder.
Yeah. So can you share your file? Can you please check?
Yes.
Yeah, check. Please check.
So my screen is visible. Hello.
No, it is still not visible. Please share that one. I already make you co-host.
So I have shared my screen, but due to some network issue, I think it is not visible to you.
Can you
sir, is it visible now?
No, till now I cannot see that one.
Okay, sir. I start again.
Yeah, it's still. Yeah.
Now, sir,
we can see that one now. Yeah, thank you.
Okay.
Please continue your presentation. Thank you very much.
Okay, sir. Sir, I have presented this paper on the behalf of my students. I am working in KITE group of institution, and my scholar, Dr. Ruchirani Garg and Aarti Sharma. Aarti Sharma is one of my student in KITE group, and they are absent today. So I present this paper, Mental Health Analysis on Twitter Data. Basically, this paper is about the mental health disorder. There are a lot of mental illness in today's world, like anxiety, depression. Okay, so we have did analysis in this paper to extract that mental illness or to identify mental illness. Okay, as I see, increases in occurrence and global burden of mental illness have made the prevention and treatment of mental disorder a public health priority. According to survey that we have did in 2017, US report showed that estimated 46.6 million adults have been affected by mental illness. Actually, in this paper, what we did, we collect tweet from Twitter. Lots of people tweet from Twitter as a data set. And on that tweet, we perform a machine learning approaches to analysis what type of mental illness a man can have or a woman can have. According to their tweets, we collect their tweet from Twitter. Okay. So these are the related work. Basically, if we apply artificial intelligence, AI, for identification of mental health, it would be great. It would be great to identify mental illness if we apply artificial intelligence, because in AI we have several machine learning approaches through which we can identify which type of mental health issue to a particular guy by the help of its tweet. So these are the mental health disorder we identify on the basis of individual tweet. It will lie in this category. The first one is depression. Okay, depression is like when a particular feels sad, okay, or lose interest in everything. So this category will lie in depression. A second one is anxiety disorder. Anxiety disorder is something suppose someone not behave normally in common condition. In common condition, always behave abnormally. So it will lie in anxiety order. The third one is bipolar disorder. Bipolar disorder means suppose one guy have a problem of mood swing. In some mood, it will feel very depressive, and in some mood, it will be very excited. So it is a bipolar disorder. Sometimes it feel very low. Someone feel very low. Someone feel very lonely and very sad. And in some time, it feel very excited. Someone having a eating disorder. The fourth category is eating disorder. Means some people having a problem of overeating. They don't know their stomach is full, but they continue eating and eating. So it will lie in eating disorder. The last category is PTSD, post-traumatic disorder. Okay. Basically, this type of disorder, PTSD disorder, basically when someone have a tragedy in past, some tragedy happens in the past, due to which a particular guy lie in this category, PTSD, post-traumatic stress disorder. So this is the problem statement. Depression is a common mental disorder. Globally, it is estimated that 5% of the adults suffer from depression. Basically, our research objective is to use machine learning approaches to analyze various tweet, and on the basis of tweet, we have to determine which guy lie in which category of disorder. So this is a methodology flow chart. The first one is data collection. Data, basically, my students collect data from Twitter, and for that they use Python and import Twint library. Import Twint library to collect data set from Twitter. After they applied data visualization technique, because there are various data visualization technique, very data visualization library in Python, and they apply machine learning algorithms. After that, they evaluate and deploy. As I said you that data that they extract, they extract data from the Twint library. I've clearly mentioned in my slide that they extracted the data from Twitter with the help of Twint library. Basically, Twint is a Python library for Twitter data stripping. Okay. In this, we can also use Twitter API, but in Twitter API, there is a problem of authentication. So we apply, we use Twint library. Okay, Twint does not have the some benefit over the Twitter API, such as being easier to use, because Twint library doesn't require any authentication or API key. That's why I think my students use Twint library to extract data set. Okay, so the student extracted data from 5 disorder. Okay, PTSD, anxiety, depression, eating disorder, bipolar. They extracted data. They have collected around 8,500 tweets about anxiety, 8,000 tweets about depression, 7,000 tweets about PTSD, 6,000 tweets about eating disorder, and around 4,000 tweets about bipolar. Okay, you can see here. I have drawn the they have drawn the graph. Around 8,500 tweet they collected for anxiety. Around 8,000 tweet they had collected for depression. Around 6,000 tweet they had collected for PTSD, polar trauma disorder, and around 4,000 tweet they had collected for eating disorder, and 2,000 tweet for bipolar. Okay. After collecting of data, they apply data cleaning. Data cleaning is a very important for improving the data quality and reduce bias and save time and resources. For data cleaning process, they have used various libraries such as NTLK, Spacey, and Text Blob library for data cleaning. Basically, and NLTK is a Python library for natural language processing, such as tokenization, stemming, lemmatization. Okay. So they have designed. Okay. So next slide. These are the sample instance of collected tweet. Well, on the basis of tweet, how they categorize that particular tweet is like in depression. Okay. Suppose the first tweet is, I was like trying to open up, like, yeah, I struggle with depression, have for my whole life. It's a kind coming in for lately and she. So these are the messages on which they apply machine learning approaches, and after that they decide that particular tweet will be lie in which category. So we can prevent or we can give message to someone about his mental illness. So we can warn anyone. Okay, because the main problem with mental health illness is that nobody knows, yeah, nobody care about his mental health illness. Okay, these are the machine learning approach. Machine learning has shown a lot of potential for solving healthcare issues. Student apply these algorithm: logistic regression, naive Bayes, SMVM, random forest, and gradient boosted classifier to check to identify for classification, to develop a classification model. And with the help of classification model, they classify into categories like depression, anxiety. So for that, they apply machine learning approaches. Okay, these are the accuracy of various algorithm when they apply. Logistic regression give 87.8 accuracy. The naive Bayes give 82.2 accuracy. Support vector machine gives 87.39 accuracy. Random forest give 87.1 accuracy, and the last is gradient boosted classifier give 90% accuracy. The maximum accuracy they gain in gradient boosted classifier. So these are the references that the students used in class to develop a classification model. That's it from my side. Thank you, sir.
Thank you very much, Mr. Saurabh. Thanks a lot. So any of the participant have any question? Any of the participant have any question to Mr. Saurabh? Yes, Mr. Presenter 8, do you have any
Yes,
question?
this is Jackson, but I have like two questions for doctor. The first question is like the system is all about getting information and you group it, but how do you ensure its privacy? Because the people who are providing, like the people who are giving those messages, I don't think they would need to be known. And secondly, like doctor is saying, my students did this. What was his part like in the paper? Thank you.
So actually, I just give them idea. I just give them idea to apply machine learning algorithms to identification or to develop a classification model on the basis of tweets. And it is just you can say that it is just an analytical paper. They just analysis the performance of algorithm to determine to develop a classification model. Okay, sir. I just give them idea to write a analytical paper to provide proper analysis of tweets.
Mhm. We understand, Mr. Saurabh. So you not only give the idea, you also guide them. We understand the point. Okay, so anyone have any other question? Okay, Mr. Saurabh, thank you very much for your amazing presentation. Thanks a lot.
Okay, sir. Thank you, sir.
Thank you. So paper ID 7961, presenter 4. Paper name is hybrid classifier for software defect prediction by using filter-based feature selection technique. So presenter 4 is present here. Presenter 4, paper ID 97961, hybrid classifier for software defect prediction by using filter-based feature selection technique. So it's present here. So presenter 5 is there. Presenter 5, paper ID is 9717, evaluating the effectiveness of deep learning algorithm, a comparative study. Presenter 5, paper ID 9717. Presenter 4, paper ID 7961, hybrid classifier. Presenter 6, paper ID 751, Edge computing for big data analysis is present here. I think they are not present, so let's wait for a while for them. Thank you. Hello. So presenter 8, you can presenter 8, paper ID is 1304, web-based employee promotion prediction using random forest classifier. So you can present your presentation.
Thank you, Professor.
Just wait, let me make you give you the permission to share your documents.
I ready.
No, no.
Is everyone can everyone see, please?
Excuse me.
Professor,
Yes.
can you see, because I've already shared?
Yeah. I can see. We can see. So please continue.
Thank you.
Thank you, Mr.
Yes.
Jackson.
Good afternoon, everyone. I'm Jackson Tohairwe, and my co-authors that are not available, we are 3 authors of the paper. Jackson Tohairwe, as I already said, and Jonathan Kalibara Mukisa, and our supervisor, Ahmed Abdul Karim Al Absir. But they are in absence, and they sent an apology. Our paper is web-based employee promotion prediction using random forest classifier. And I will briefly go through it. Okay. Table of contents. I'll talk about the introduction, objectives, research significance, what do we mean by employee promotion and employee promotion prediction, materials we used, like the data sets, resampling, prediction models, evaluation, performance, system architecture, contribution, limitations of the research, and the future scope. In brief, introduction. Promotion is the assignment of responsibility, authority, and pay increment. Promotion is one of the most vital topics in employees' lives, and working with promotion expectation gives a morale, gives to an employee, and its absence is more likely to cause employees to live on their own, because employee promotion is a must to happen for both the companies and the employees, and should be performed in a correct way, fair and biased, as well as right manner. A prediction model is built to solve challenges of gender inequalities, bias, and promotion without complete facts. In brief, like the traditional way of promoting employees or promoting people who are working for us, we are always aiming at, you look at someone, maybe the way he's working, you gauge on, sometimes, of course, some, like, let me say, some companies may base on some characteristics or features, but most of the times it's based on who knows who does what. But the system we are trying to, me and my colleagues, we are proposing, will not be looking at, oh, this is a woman, this is a man, this is my friend, this is my relative. No, it won't be looking at that. It would just be taking in some features that we shall discuss in the near future, and then giving out the result, who should be promoted and who should not. As I already said, what's the objective? The purpose of this study is to explore and visualize the HR dataset from Cargo in order to adapt a machine learning algorithm to predict employee promotion status. The model is optimized using machine learning techniques such as synthetic minority oversampling technique, which is SMART most of the time. Most people symbolize it by SMART, so that the support system can generate a set of insights and recommendations that will help the company make appropriate decisions. Research significance. Why do we really need this? Employee promotion benefits both the employee and the company, because it assures efficient and effective work outputs, which in turn boosts motivation and production, as well as retaining of the best talents and reducing attrition, which the employees are hoping to be recognized for their efforts in the form of promotion. As I already said, for companies, when an employee is working, hoping to be promoted, he's giving all he has, and not only giving all he has, as he's giving all he has, expecting a promotion in the near future. Expecting a promotion in the near future, the returns or his effort will be leading to high productivity to the company. The company gets revenue and the employee gets a chance to be promoted, which is a win-win situation in a normal language that we use. Then slide 6, employee promotion prediction. When you think of this, what comes into our mind? Promotion is defined as an appointment to a post requiring higher credentials, such as greater skills or more experience, and entailing a higher degree of responsibility, a higher rate of pay, and a change in title. This work intends to construct several features and apply a machine learning algorithm to predict an employee to be promoted. When you think of promotion, first and foremost, you have to change title, you have to get high pay, you have to get a job where maybe if you are applying some skills, now you'll be applying skills that are more than what you were applying. And most of the times it's experience matters, because you cannot be just, you're from maybe school and then you get a promotion. Of course, your degree gonna matter, as we shall see the futures we based on to make the system. Next is, I'll talk about the materials that we used. In this study, a data set of 54,808 rows and 14 columns from Kaggo's publicly accessed employee values is used. The dataset we used is a publicly outsourced in Kaggo, and it's an HR dataset. And the dataset was broken down by Mike Collins, Global Vice Chancellor, Workforce of Analytical and Planning Solution Strategy, and the Chief Expert at SAP Success Factors. SAP Success Factors it's a company where this dataset was the people that provided the dataset to Kaggo, in brief. So now these are as we already said, it has 14 columns. These will be the columns that will be based on employee ID, department, region, education, gender, recruitment channel, number of trainings, age, ratings, length of service. This is the experience I talked about. The KPIs metric. This is key performance indicators, awards won in the last years or previous years. How many awards did you win? Then average training score, how many trainings have you done and what's the average of the score is promoted. Now, this is where the system will be basing on. We'll take in these features and then it will be showing, should an employee be promoted or should an employee be stay on the same position? Then first and foremost, the dataset we are using, the HR dataset from Kaggo that is outsourced, is highly imbalanced. The dataset's target variable is promoted, produces a binary output considering 1 to, if we consider 1 to be promoted and 0 to lacking or to no promotion, the dataset will reveal 91.48 chances of outcome that there is no promotion, which means if you just choose at random, he's not promoted, you are 91% something correct. And this is one of the biggest challenges. Why? Because most employees in the company, in the success factors, they were not promoted. But we used techniques, as we shall. Yeah, the figure below shows 0, which we said is lack of promotion. Almost out of 54,000 something, 50,000 people were not promoted. That shows you how imbalanced or biased this dataset is gonna be. But we tried, me and my colleagues, to to balance it or to remove the bias in the data set by using the resampling techniques. Resampling is done on the data to avoid potential and unforeseen side effects. And there are many techniques for the data resampling. But for this case, we shall look specifically at SMART, as I already said, synthetic oversampling technique. SMART algorithm works by it will randomly pick the minority class and calculate the k-nearest neighbor for the point, and then synthetic points and are added between the neighbors and the spot chosen. It will be trying to reduce the distance between the 2 points. Then now I will go to prediction models of the data. What algorithms did we apply? In this research, modeling is done by selecting a variety of predictive machine learning algorithms, putting them to use, and then validating the best model based on metrics like classification report and confusion matrix, and the method will include support vector machine. Support vector machine, regression and classification of linear and non-linear are done by using support vector machine. The hyperplane should be chosen for best results to be determined. The boundary of the choice is hyperplane because the decision boundary can be formed correctly, and linear classification, it works well. Nevertheless, residential data is produced with linear classification, with non-linear classification, making it challenging to classify the points into promoted or not promoted. It will be a little challenging to categorize them. Kernel function is utilized. It can be applied to facial analysis, handwriting and algorithms, and etc. Then second is random forest classification, which is the one we actually focused on. But though we applied all of these, then we chose the one that gave us the best accuracy and F1 score. This approach is preferred for classification and regression analysis based on the construction of multiple decision trees. The approach is inspired by ensemble learning. Many decision trees are generated using this machine learning technique known as banging approach, which involves choosing more than one subset from the data. In particular, random forest is made up of many different decision trees that are constructed. What I'm trying to say here is random forest, it's a group of many decision tree classifiers. So if decision tree can give one, let me say, like the accuracy to 20, so a group of random forest will be increasing its accuracy and performance. Then we use the logistic regression classifier. A regression model called logistic regression fits the values of the logistic function. When the dependent variable is categorized, it helps the model to avoid overfitting. Regularization techniques are frequently combined. Then lastly, I'll talk on decision tree, which is known as DTC. Is a tree in which leaf node represents a decision and each branch node indicates a choice among several options. This method evaluates the discriminatory power of each property using the information provided. Then next, I will go on what did we base on to evaluate. After applying the four machine learning algorithms, what did we base on to evaluate? We based on a few metrics rated to the assessment, success, and strength of the model are gathered after trained data using approaches. Accuracy, precision, recall, and specificity are evaluated measures, and finding that show the power and performance of the models. There are four things that we based on: accuracy, precision, recall, and decision tree. When we talk of accuracy is the number of correct classification divided by the total number of the classifications. You get the TP, we normally symbolize it, which is total positive plus total negative. You divide by the total number of the output that you have. I didn't include the formulas, but I will briefly show my paper easily. You can see everything in it. Then precision is the percentage of positive results that are genuinely positive, something like the results that are positive and really true positive, which is true positive divided by true positive plus false positive, only the results that are positive. Recall is the ratio of how many of the data are actually positively will be predicted as positive, something that is positive and will come up as positive, which is true positive divided by true positive plus false negative. F1 score, outcome of combining recall and precision. If you get the precision and recall, add them and get the average, what you get is, it will be our F1 score. So system architecture, how will our system look? First and foremost, the data is balanced using the techniques, which I said SMART specifically, we'll use SMART. And again, it will be passed through the machine learning algorithms, the one I said before, the SVM, RF, DT, and DTC and logistic regressor. So that prediction can take place. As a result, the model produces classes labeled as either 0 for non-promotion or 1 for promotion. As we are saying now, we train the data. That is, after you train, you visualize, you resample, then the data you get, you pass it through the promoted samples before SMART. Then now here, the non-promoted, like the promoted samples will be balanced now. Like, so we have eliminated the, let me say, the imbalance, the data imbalance. Now it will be at the same verge of 50-50. Promotion is promoted is 50 and no promotion is 50. Then in case maybe like you want to take it non-promoted samples, you can just bring it from the data you're training is not promoted. Then now applying machine learning algorithm. Here you will apply the machine, like after resampling the data and the data is fully balanced, sorry, you can't see. Then you apply the machine learning algorithm, which is the RF, the support vector machine, the logistic, and yes, and the DT. But DT I didn't include it because it is within the random forest. We said it's a group of multiple forests. So now after passing them through, you have to come back. Now the system will be passed into our prediction system, which we used Python, which is Spider, to make our web-based employee promotion system. Now it's the testing data and now the testing results. Now the system here, the system prediction model will be able to show 0 or 1. Next. Performance of the results. Choosing an accurate model for unbalanced data set requires more than just accuracy. You cannot just look at the accuracy, the precision, and recall, and then come up with a system that you choose. Without using any imbalanced procedures, accuracy rates are high, but recall and F1 score values are relatively poor. The model is chosen after consideration of F1 score, and that's why in this paper, random forest was picked to be used for prediction, as it returned the highest accuracy, precision, recall, and F1 score. After seeing like SVM, which is support vector machine, its accuracy and precision and recall, I think everyone can see the table that's here. We chose random forest, RF. Why its accuracy, precision, and recall is they are so high, and making the matters worse or best, it's F1 score, which we based on to choose our decision-making system, is 95, which is the higher of all the other algorithms that we applied. Then what was the limitation that we faced? The difficulty of assessing some information, we encountered certain challenges while trying to assess information, particularly official documents that some agencies may refer to as confidential. This has an impact on us since we are unsure of traditional methods of promotion. We are absolutely not 100% sure of the traditional methods that they were using to decide and say, this one is promoted. Why? Because we couldn't find documents, and the documents that were available, they couldn't give them to, like, make them online. We could not access them so that we can read and know. Maybe they were basing on age, they were basing on this. We are really not sure of what traditional methods were 100% considering to promote someone. So, and the reason, improve the future methodologies as well as dataset is highly imbalanced, and it will be predicting 91% no promotion, as I already said, and one chooses not promoted will be 91% correct, and this shows less chances of promotion. What would we like to do in the future? The proposed system is web-based application, and then we plan to make its multiple to make it a multi-system application where you can download it and use it in your company in anywhere. But to do that, so like in the future, that's the thing we want to do. And again, we want to apply future engineering and future importance to the study by using other data balance techniques, or maybe there are also the updated data set. So now we talk of contribution. We used a real HR dataset from Cargo for this project. Exploratory data analysis was performed first, training and data splitting. Our data was then adapted into several machine learning algorithms, basically four. The variable employee promotion prediction is a computer-based the variable employee promotion prediction is machine learning system, considering the most of our HR managers may not be computer-based specialists. So we propose, like the web-based application, we are giving, most people don't, like in case an HR is changed, so he will not come to go into the books to read which employee to promote. So for us, that's why we came up with saying, if the system already has everything, the awards each employee has, employee ID, has the KPI, as I already showed here. The system already has everything: education levels, gender, recruitment channel, average training score. So if an HR has been changed, you still don't need to worry. What you just need is an employee ID. You put it within. In this, you just put an employee ID, it will generate to you. Should he be promoted? No. Should he be promoted? Yes. Then you can go with it. That's basically the contribution that we did for this. The system will print employee ID entered together with each employee's percentage training score from the scoreboard and whether they should be promoted. In conclusion, a web employee promotion prediction model is put out in this study using RF approach for the HR managers and other decision makers involved in the employee promotion. A system for determining eligibility and promotion flexibility is developed. The F1 score is vital because it's important to have a measurement tool that considers all mistake costs in addition to false positive or false negative. HR can use this study to increase the efficiency, the effectiveness of the performance over time and raise the KPIs for promoted jobs. Thank you. Thank you for your attention. But before I finish, I would like to show you my paper, how it looks like. Yes, I think everyone now can see it again. This is the web-based paper. First was introduction. We talked of the problem statement, objectives.
Mr. Jackson, thank you. I think you do not need to show the paper. It's okay. So we understand.
Okay, Professor. Thank you.
From the presentation itself. Okay. So can you please go back to the presentation?
Okay, Professor.
Thank you.
Yes, I'm back.
Okay. Thank you. So any of the participants have any question for Mr. Jackson?
Yes, I actually have a question for Jackson.
Please go ahead.
Yes, Mr. Jackson, I'm highly interested in your paper because of the way it handles its data. So I wanted to ask, how does your model handle data bias? Because most models, like once they're trained on historical data, if like, let's say in your data set, you had like education background and then gender. So if the model was trained and it picked people, like it was favored people like from particular school and of a particular gender, does your model also have this kind of bias, or yours also presents some kind of solution towards it?
First, thank you, Amias, for the question. As I already showed you this table, like education, actually, I didn't explain more of it. Education, we considered bachelor's, master's, and PhD. And it was, you know, this in the system, you cannot predict using master's or degree or what. So we had to convert them into, we call it numerical data, which is either 1 to be 0, 1, and 2. So if maybe, of course, it won't be biased because we gave each, if you are on PhD, we gave it a percentage. It will be considering you as 30. If you have like 30%. And as I already said, the score band will be containing average training score. So the 30% will be like an addition to what you'll get in gender, which gender won't be considered in the recruitment channel, in the number of training. It will just be giving the average score, and the person with the highest score, of course, will be standing the highest chance of promotion. I don't know if that has answered your question, Amias.
Mr. Jackson, Amias' second part of the question, he also mentioned about the specific schools. Let's suppose the high-ranking schools. Do you have a bias for the high-ranking schools, or
no,
a bit moderate schools or lower rankings, or you will just divide the section with like a bachelor, masters, and PhD?
Sorry, Professor, about that. Like the data set we used was just like, it only provided a column education with 3. It didn't take in school maybe from Seoul University, from KD, you know. It's just based on the level of education that you're having.
Okay, we understand. Thank you very much. I have one question. So anyone else have any other question? I would wait for my question. Anyone else have any other question? Okay, thank you. So Mr. Jackson, I have one question. So you mentioned that that support vector machine case. So which types of that kernel function we use in the support vector machine?
Sorry?
I saw you use support vector machine, am I right? SVM.
Yes, yes.
So SVM case, which types of kernel you use, kernel function?
Sorry, like Professor, like we used like the hyperplane for it, like support vector. I don't know if I can. Like we used like the hyperplane basically on it.
Yeah, hyperplane, but the support vector machine specifically work with specific kernel functions to generate those hyperplanes. So which types you use? Linear one, or radial bias one, or polynomial? Which one?
No, we used the Dorado basis function.
Dorado basis function?
Yes.
Okay. Okay. I understand. Okay, thank you very much. Thank you very much, Mr. Jackson. Anyone have any other question to Mr. Jackson? Okay, thank you, Mr. Jackson, for your amazing presentation and amazing work.
Thank you, Professor.
Okay, thank you. You can stop sharing your screen. Thank you. So is presenter 4, presenter 5, presenter 6, and presenter 7 is there? Presenter 4 and 5, I believe they are not here. So presenter 6, paper ID 751, H computing for big data analysis is there. Presenter 6, H computing for big data analysis is there. Presenter 7, paper ID 4047, real-time system for air quality forecasting, a review of sensor network data fusion and modeling approach is there. Presenter 7. Okay. So we will just wait for presenter 6. So if when presenter 6 comes, shows, we will one more presentation. Presenter 6, are you there? Presenter 6, paper ID 751, H computing for big data analysis.
Yes, sir. Yes, sir. Sir, just a second. My friend is also joining too.
Okay. Okay. Can you please make it a bit fast? Presenter 6, are you ready to present?
Sir, just a second, sir. My partner is also joining. So just
Okay.
a minute.
Okay, so we'll give you a file. So when we will start, share the file at that time.
Okay,
I think Mr. Devraz, they
morning,
is
yes,
your
sir.
partner, am I right? So yeah, please continue. Please continue.
So,
So-
am I audible?
Yeah, we can hear you. Okay.
Just a second, sir. I will change my name.
No, it's okay. It's okay, no problem.
Okay.
I can understand because your partner is already put the ID of that presenter 6.
Okay.
So no problem.
Okay.
Thank you. So please start your presentation. Okay. So I will now mute. Thank you.
Okay. So, good morning, everyone present here. We are here to present our conference paper titled An Overview of Edge Computing for Big Data Analytics. We, the authors, myself, Debraj De, along with Siddharth Sasde from KIIT India. So let's begin. Next slide. So here are the topics on which we are going to talk today. First of all, we are going to start with the introduction of edge computing and big data. Then moving on to the architecture of edge computing, then security aspects of both edge computing and big data, the technology that empowers big data analytics at edge, different approaches of edge computing, step-by-step guide, potential limitation with some examples. So let's get started. Next slide, please. So what is edge computing? The objective of edge computing paradigm is comprises of moving computation resources and services closer to the network's edge. Here the client's data is processed at the periphery of the network, as close as possible to the originating source of the data. This enables faster processing, lower latency, better user experience, and reduces network traffic. So now let's shift our focus to the origin of edge computing. There are two phases. First phase is the idea phase, that is from 1990s, and the second phase is the edge phase, that is 2020s. The principle of edge computing may be traced back to the late 1990s when Akamai initially developed CDN, that is, the Content Delivery Network, to improve web speed. A CDN retrieves and stores web content in advance at the network edge in the proximity of users' devices. In 2000, Akamai built the first version of edge computing to combat the problem of worldwide wait. Worldwide wait is a term that is used for World Wide Web by the users who suffer from low speed connection. Now coming to the characteristics of edge computing. The characteristics are as follows. Dense geographical distribution, mobility support, location awareness, low latency. So in dense geographical distributions, it implies that there is a higher degree of connectivity, accessibility, and effectiveness because the elements are closer to each other. Mobility support in edge computing involves infrastructure adapting to mobile devices and users, ensuring seamless connectivity and uninterrupted service delivery. Location awareness is the ability of edge devices to identify their geographic location and use this information to improve their computing activities. Low latency. Edge computing shortens the distance that the data has to travel by locating the computing resources closer to the originating source of the data. This configuration lowers the latency and enables real-time data analysis and response. Now coming to the next slide. So now coming to introduction of big data. We all know what big data is. We can say big data as a collection of data that is huge in volume and that is growing exponentially in time day by day. It has the potential to transform various fields such as business, healthcare, education, and management. Big data came into picture since 1990s and its popularization is often attributed to John Marshall. He is the one who has been credited for being the first to spread the term and the concept of big data. Big data mainly originated in early 2000s when the internet growth exponentially due to introduction of Like the data is coming from Facebook, social, Instagram, and many IoT devices are also generating the data. In 2013, the world's data was estimated to be 4.4 zettabytes, and it is projected to increase rapidly to 44 zettabytes by 2020. Now, some characteristics of big data. Big data is basically characterized by five V's. Those are volume, variety, velocity, veracity, value. Volume refers to the amount of data that exists. Velocity refers to how quickly the data is generated and how quickly the data moves, or we can say that how quickly we need to handle the data. Variety refers to the diversity of data, means the data is either structured or unstructured or semi-structured. It is a text file, audio file, video file, JSON, etc. Veracity refers to the quality and accuracy of the data, means how accurate the data gathered is, whether we can get something from the data or the data is useless. Value. Value refers to the value that big data can provide. It is directly related to organizations, what the organizations can gain from the collected data. Next slide, please. Now coming on to the architecture of edge computing. Edge computing architecture is a federated network topology that uses edge devices to connect to the terminal device. It is mainly divided into three layers. The three layers are terminal layer, edge layer, cloud layer. Terminal layer is the last layer and consists of devices that are linked to the edge network. The devices such as smartphones, sensors, smart cars, and other IoT devices. These devices serve both as recipients and providers of data. Edge layer. The edge layer permits terminal devices to connect from below and also stores and processes the data that has been uploaded by the terminal devices, and it connects to the cloud and transmits the processed data there. Cloud layer. The cloud layer is made up of numerous high-performance storage devices and servers that processes robust storage and computing abilities. The data center saves the data delivered by the edge layer for an extended period of time and undertakes tasks that involve analysis which cannot be executed by the edge layer. Next slide, please. Okay. Next slide. Yeah. So now coming on to the security aspect of edge computing and big data. Since edge computing is a new technology, it has security flaws. It has many security flaws, especially when dealing with massive amount of data. Some of the flaws are like data breaches. In data breaches, since edge computing processes and analyzes data closer to the network's edge and closer to the source of originating, means the originating source of data. This means the data is frequently kept and processed outside the network organization's core data center, increasing the possibility of data breaches. Data storage, backup, and protection risk. As previously stated, data kept at edge lacks the physical security safeguard of data centers. In reality, we can say that stealing a complete database may be as simple as removing a disk from the edge computing resources or inserting a simple file drive to copy the data. Access control. Because data is processed and analyzed outside the organization's core data center, edge computing creates additional access control parameters, policies, or techniques, which is necessary so that the access control is maintained and any outsider cannot access or edit the data. Password and authentication risk. Edge computing resources are often neglected by the security IT professionals, which may lead to like weak password discipline and insufficient use of robust security techniques, like we can say two-factor authentication, multi-factor authentication, OTP, etc. Network security. Edge devices are partially vulnerable to network-based attacks such as malware, denial of service attack, since they are frequently linked to the other devices or systems which are connected to the internet. Network security measures such as firewall, intrusion detection system have to be robust and installed in a proper way to protect the system from such threats. Now coming to the security aspects of big data. We all know that many businesses employ big data, and it is necessary also, but they may not have the right environment in terms of security, which may lead to identifying attacks, intrusion, data deletion, etc. Some of the security aspects are as follows. Privacy. The handling of sensitive data presents a problem for big data. In terms of security, such as encryption and blind processing, these technologies handle all data equally and do not differentiate between the data types. Because it handles the sensitive and non-sensitive data in a similar way. So it's like risk, lack of access control. Big data environments often include several people, applications, systems, devices, accessing the data and processing the data. Without suitable access control in place, it is tough to check who is granted the access to edit, who is granted the access to delete. This can result in unwanted access of data, data tampering, or data loss. Lack of transparency. Big data analytics can include complicated algorithms and processes, which make it tough for businesses to understand how decision-making is done. So this lack in openness of decision-making and may raise questions about discrimination or biased decision-making, which may be a legal aspect or which can hamper the reputation of a business. Communication. Data is distributed across clusters worldwide with communication via private and public network. Secure network protocols are crucial for preventing inter-party interaction and also for ensuring data integrity. Malware and other cyber threats. Malware, viruses, and other cyber threats are also present in big data contexts. Attackers can exploit the bugs or software flows, or they can easily infiltrate the system using social engineering, reverse engineering, or simple phishing techniques. So this was from my side. The next topics will be explained by Siddharth. Thank you.
Thank you, Devraj. So let's begin with the topic, the cutting edge technology that empowers big data analytics at the edge. So we know that edge computing refers to the process of performing data processing and analyzing closer to the source of data generation rather than relying on the centralized cloud infrastructure. By bringing computational capabilities closer to where data is generated, edge computing enables right-time or near real-time data analysis, which reduces latency and enhances privacy and security. Thus, given below are some of the cutting-edge theories. Let's begin with it. The first one is edge computing technologies. So we have edge devices and edge data centers. Edge devices, these includes IoT devices like actuators, cameras, sensors, etc., which collect data at the network edge. The second one is edge data centers. These centers provide more processing resources and storage capacities than edge services. Second, data acquisition and pre-processing. It contains data collection, data filtering and aggregation, and data pre-processing. The data collection collects the variety of data sources, includes sensors, IoT devices, external systems. In the data filtering and aggregation, we use this to decrease the amount of data provided to centralized infrastructure. Hence, edge devices undertake initial filtering and aggregation. Third, data pre-processing. It is used to increase data quality and reduce processing burden at the central infrastructure. Then, edge analytics. We have local data analysis and local analysis and stream processing in it. So the local data analysis, the real-time analysis are performed on the real-time analytics are performed on pre-processed data by edge servers. In the stream processing, we have stream processing frameworks like Apache, Flink, AWS Kinesis, and which is used to process real data streams from the edge devices. Then we have data storage and management. It contains edge storage, data synchronization, and data lifecycle management. So in the edge devices, Edge devices retain relevant data for a set length of time. This provides resilience during intermittent network disruption or poor conductivity by allowing immediate access to data for local processing. In the data synchronization, we ensure that consistency and reliability mechanisms for synchronizing edge data with central infrastructure should be implemented. Then in the data lifecycle management, we optimize storage resources and comply with data governance rules policies for data retention, preservation, and deletion. Now, security and privacy considerations. It contains encryption of data, access management, privacy protection, and the deletion of abnormalities. In the encryption of data, SSL and TSL encryption algorithms are used to safeguard data transmission between edge devices and the central infrastructure. In the access management, to prevent unauthorized access to edge devices and data, we reboost access control techniques, and this helps to control to prevent the unauthorized access. In the third, detection of abnormalities. Abnormality detection algorithms can be used in edge analytics to detect potential security breaches or aberrant behavior in real time. Fourth, privacy protection. In edge computing reduces privacy issues by processing sensitive data locally rather than sending it remotely servers. Now moving on to the.
I'm sorry, Mr. Siddharth, I'm sorry to interrupt you, but your time is almost coming to finish. So can you please go a bit fast?
Okay, sir.
Thank
Now
you.
moving on to the next slide, we have different approaches for edge computing for big data analytics. It contains of two types: analytics on edge and edge cloud analytics hybrid. In the analytics of edge, we have edge devices which perform data processing and analytics, offering real-time insights and reduced bandwidth needs. In the edge cloud analytics hybrid, we have edge computing and cloud computing architecture, which combine together to have analytic tasks and offer scalability and global context. Now moving on to the next slide, we have step-by-step guide on how to implement edge computing for the big data analytics. Here we contain 9 points, which are define, use case, and requirements. Here we determine exact big data analytics use case and benefits of the edge computing. Then we have to identify edge devices and infrastructure. Then we determine data acquisition and pre-processing. In the determination of data sources, we use the technique to collect data, and then we analyze it. Then we have edge analytic implementation. In the edge analytic implementation, we choose the best analytic algorithm and models for the edge computing. Then we have data storage and management. Here we determine the storage needs and data storage management at the edge. In the security and privacy consideration, here we access security threads and put step-by-step place to protect edge devices. Then we have connectivity and communication. Here we create a strong connection between edge devices and the centralized infrastructure. And same we do with the communication system. In the deployment and management, here we deploy the edge computing infrastructure and devices in accordance with the agriculture specification. And the last, evaluation of optimization. Here we continuously monitor the edge devices, edge computing solution performance and efficiency. Now moving on to the limitations. Here are some limitations given below, that is specialized hardware and software requirements, the data processing capabilities, security and privacy risks, network bandwidth constraints, and increased complexity. In the specialized hardware and software requirements, we generally comes with the challenges like the maintenance capabilities and existing systems, and lead to increased cost of deploying and maintaining these specialized resources. In the data processing, since edge devices have limited computation capabilities, they don't process massive data. So we have a real-time data problem and insight in response with the user queries. Then we have in the security privacy risks. Edge devices are frequently used in untrusted and open situations, making them more exposed to the security attacks. In the network bandwidth, here the problem arises like they are due to the transport of data between edge devices and centralized infrastructure. Edge computing completely relies on the network bandwidth. So due to limited bandwidth networks or which can implement real-time data analytics can cause transmission delays, reducing the responsiveness of the edge analytics. Then we have increased complexity. Due to the complication derives from need to manage data processing, storage, analytic amount of several edges of the computer, dealing with the variations in edge devices, fluctuating networks and circumstances, and ensuring data consistency across distributed systems can signify increase in the overall system complexity. Then we come to the last topic, which is applications of edge computing with big data. We can use edge computing in our daily lives, like in the following examples given below. Like the first, we can have smart homes. The sensors in smart homes capture temperature, humidity, energy consumption, which is subsequently processed by edge computing devices. We can use it in healthcare, as edge computing are utilized in healthcare business to process and analyze massive amounts of patient data. Then we can use it in traffic management, as computing devices in traffic management can collect data from traffic cameras, sensors, and GPS devices. In transportation, we can use it as to analyze from connected vehicles such as cars and trucks. So these were our references which we used.
Okay, Mr. Siddharth, please. Okay, so we understand the references. So, but the problem is you talk means we already understand your point. So thank you very much for your amazing presentation. So
Thank you, sir.
my question is, can you share the slide, please?
Yes.
My question, I have a question because you guys means you and your partner already discussed about the processes, and also you guys implement the algorithms, but I didn't get any results of those algorithms. Did you get any results about that algorithm that you already applied? So how much security, how much means computing is done? So we do not have any analytical result of that one. Means any types of analysis you did with those algorithms, how they perform, we do not have any idea about that. So do you have any results?
Sir, actually, it is a new theory which is like upgrading day by day.
Oh, okay. So
we didn't have much data about it. Like we haven't analyzed till now a lot.
Understand, means in near future you are going to apply those algorithms. Means it's just a hypothetical study, but in near future you can apply that one. Am I right? And
Yes, sir. Yes, sir.
Okay, okay. Understand. Okay. Thank you very much for your presentation. Okay. Thanks a lot.
Thank you, sir.
Thank you so much, sir.
Okay. Thanks. Have a nice day.
Thank you.
So at this point we will have a 10 minutes, 20 minutes break. So it's around 1:03 now. So we will start the next session around 1:20. Okay. So enjoy your break. Thank you very much. Hello everyone. Let's start the second part of the session 2 regarding the smart embedded system. So, presenter 7, are you there?
Oh, yes. Hello.
Hello, good morning, good afternoon.
Good afternoon.
Yeah.
Oh,
So let's start. You can start your presentation.
yeah, sure.
Thank you.
Good afternoon, Smart Cyber team and participants. I am Sukina Viki, a master student from the Industrial Department, University of Busan, and I am presenting today my review paper named Real-Time System for Equality Forecasting, a review of sensor network and data vision modeling approaches. So in this presentation, we can give an overview of the recent developments in real-time modeling methods for efficient air quality management. We're going to focus on the most recent improvements in wireless sensor network and emphasizing their uses in scientific developments, and we're going to explain the significance of data vision techniques in air quality monitoring. And then we're going to discuss their applications in various scenarios. At the end, we're going to cover some real-time modeling techniques and their useful applications. So in last decades, millions of people around the world's health and well-being are impacted by air pollution and serious environmental problems. So for early detection of possible air quality issues and the creation of efficient and mitigation plans, accurate forecasting is really crucial. And to offer timely updates on the state of the air and increase the precision of air quality forecast, real-time system can be employed. So in recent developments in wireless sensor network have made it easier to employ them for a variety of purposes, such as environmental monitoring. And in recent years, there has been a lot of interest in using wireless sensors, wireless sensor networks to monitor air quality in particular. And the ability of wireless sensor network to deliver real-time information on air quality factors, including temperature, humidity, and pollutant concentrations, has been highlighted in really number of studies. Several studies showed that using wireless sensors network can produce trustworthy and accurate data on air quality, which can assist guide policies meant to improve air quality. Recently, many researchers actually emphasize how wireless sensor network can deliver real-time information on air quality that may be used to create efficient air quality management plans. And in latest studies contend that combining wireless sensor networks and Internet of Things can improve air quality management by increasing the precision and effectiveness of air quality monitoring systems. We're going to explain a bit about the data vision here. So the potential of data vision techniques for enhancing air quality monitoring system has been highlighted in recent studies. And data vision actually is the process of merging information from various sources to get more precise and comprehensive pictures of a certain phenomenon. Data vision actually can assist in overcoming some of the drawbacks of individual sensors in the context of air quality monitoring, such as their restricted coverage or sensitivity to particular contaminants. So the procedure of monitoring air quality in a city using wireless sensor network is shown here, and the sensors are positioned in really different places to track various aspects of air quality, and the information gathered from each sensor is relayed to a central hub for data vision. The phases of data vision process, including data gathering, processing, and integration, are shown here. And here some data fusion process, how does it work? So here we're gonna describe the process of data fusion. In order to monitor like various air quality metrics, the initial stage is establishing a wireless sensor network in the metropolitan area. Sensors are installed in various points across the network. The sensor gather actually data on the air quality indicators and such as particulate matter, ozone, nitrogen, dioxide, etc. So the initial phase in the data pre-processing is the pre-processing phase, which focuses on normalizing and transforming and filtering raw data to get it ready for integration. The second stage includes data analysis and quality control. So in the last stage, fusion techniques such as Kalman filters, neural network, and so on, all data can be used. And this step actually generates reports and alerts based on integrated data and combines data from different sources and creates a comprehensive picture of air quality. Then afterward, choices of the management of air quality and public health are made using the combined data. So the applications of modeling approaches for air quality control has been made easier by recent developments in real-time system and machine learning techniques. So basically, these modeling techniques produce precise estimates of air quality using real-time data from air quality monitoring station, satellite data, and meteorological data. So these modeling techniques, which include machine learning, time series, and ensemble methods, help actually to increase the timeliness and reliability of air quality predictions. They make it possible to analyze sensor data in real time, capture complicated correlation, and offer useful information for managing and making decisions about the air quality. So real-time air quality forecasting has shown actually potential for artificial intelligence approaches like neural networks and deep learning. They are able to make accurate forecasts on time, adapt to shifting trends, and learn from prior data. Real-time processing of sensor data by neural networks and deep learning methods. So enable proactive decision-making and prompts actually interventions, as well as their ability to recognize nonlinear relationship and produce precise forecasts. By utilizing SVM's capacity for classification and regression tasks, real-time air quality prediction can be accomplished. So SVM models actually have the ability to interpret real-time data from sensor network and forecast air quality based on past trends. SVM actually is suited for real-time analysis and forecasting because to its capacity to recognize nonlinear relationship and manage high-dimensional data. And in machine learning, actually, random forest may be used to instantly examine a huge amount of data gathered from sensor network, and it is capable of accurately capturing intricate correlation between pollutant concentration and meteorological information in air quality metrics. So real-time air quality monitoring and forecasting can benefit from random forest capacity to handle high dimension data and produce reliable forecasts. Furthermore, the utilization of autoregressive integrated moving average models of time series analysis is considered crucial for capturing temporal dependencies and trends in real-time air quality forecasting. Actually, the ARIMA models can make short and term projections of air quality by examining historical data, including pollution concentration and climatic variables. So generally, ARIMA is suitable for real-time monitoring and forecasting since it can take into account historical observation and recognize seasonality trends. In addition to that, seasonal autoregressive integrated moving average is frequently necessary to take seasonal change in cyclic patterns into account when monitoring real-time air quality. So ARIMA models are useful for real-time forecasting and because they can efficiently capture these trends. So these models actually enable precise forecast in real time by taking into account seasonal components in the data, allowing stakeholders to respond promptly to address air quality concerns. And then another aspect to consider is in ensemble methods by merging the results of various models and adjusting to shifting trends. Boosting algorithms can improve real-time quality forecasting. Actually, boosting algorithms targets enhancing models' accuracy on difficult data examples by iteratively modify the weight of training samples since of their versatility. Boosting techniques actually useful for real-time monitoring and forecasting since they allow for precise forecast in circumstances with changing air quality. Furthermore, by lowering variance and the boosting stability, backend techniques can enhance real-time air quality forecast. Backend reduces the danger of overfitting and produce reliable predictions by assembling a set of models trained on bootstrap samples. So in real-time system, when precise and stable forecasts are essential for efficient decision-making, backend techniques are very helpful. Another aspect to consider is stacking. So to take advantage of each model's advantages and enhance real-time air quality forecasting, stacking actually mixes the forecast of various models and can identify variety, like actually it can identify various patterns and relationship in the data by using meta-learner to integrate the predictions. And a real-time system actually can benefit from stacking by incorporating many modeling approaches and utilizing their combined strength to produce a precise and trustworthy projections. So here what was above the reviewed part. Now we're gonna move to the conclusion. Actually, such system actually can be employed to educate public health profession, legislator, and the general public about potential air quality problems and to create efficient mitigation plan. So, in summary, the forecasting and monitoring of air quality might be greatly enhanced by real-time technologies. And each approach, sensor network, data vision, and modeling has its own advantages and disadvantages as well. And the success of each depends on the application for which is used and the data source available. Then the development of new real-time systems that incorporates many methodologies and data sources should be the main emphasis of future research. And in order to produce air quality forecasts that are more precise and throughout. So the overall of these researches show how real-time system and machine learning-based modeling techniques can be used to manage air quality. And finally, these methods can make precise and timely forecasts about the state of the air, which can help policymakers and the general public to take a good decision. Thank you for hearing my presentation. If you have any questions, feel free, or you can email me as well.
Thank you, Mr. Pina, for your amazing presentation and research. So any participant have any question for Ms. Sakin? Anyone have any question? Okay, I think they do not have any question, but I have one question for you. So can you please go to your models? Yeah, here is okay. So can you bring the last one? After bagging, yeah, stacking. Thank you.
Yeah.
I have a question. So did you apply any of these models?
Oh no, still I just started by reviewing like various models, and in my future plans, actually, I want to try to apply this model and make comparison between them to see which one has more efficient.
So do you want to apply all of them or just partially some of them?
Actually, I gonna just make a comparison first to see which one I be able to apply according to the seasonal and meteorological data that. So maybe not all be efficient for the same case, but generally I will first make comparison and apply them first and see if any one of these can give more accuracy with the same cases, with the same study.
Yeah. So do you have any plan to check the inference time?
Oh, yes, actually, I do have a plan. Actually, I will start working on this in my future work. Actually planning to use time series analysis on these for air quality, like by forecasting the PM 2.5 pollutants. So maybe time series maybe will be good in my case, because I'm planning to study about some air quality in different seasons like winter, spring, summer, all of them. So this is why I think time series analysis may give more accuracy to the other, but all of them needs first to be studied and need a trial first.
Okay, thank you very much. I got my answer. Thanks a lot. Yeah, have a nice day.
Thank you.
You can stop here. As you know, today is a festive day for the Muslim, our Muslim colleagues. Presenter number 9 cannot means join the Zoom session and have a presentation to do the presentation for his or her work. But they send a video, so I will share that video. Ms. Sakrina, can you?
Yes, I will unmute my.
Can you please stop sharing? Thank you. Okay, so let's see the video of the paper number 201916.
Good afternoon. My name is enhancing disease detection in areca palm leaves through active control-based image segmentation. With our team is Muhammad Rafli, Ausa Nabila Bansa, De Suryani, and Sri Listia Rosa. Introduction. Areca is type of palm family with the Latin name Areca belongs to a type of monocot plant that grows in Asia, the Pacific. The planting period for areca from nursery to ready for harvest takes about 4 years. Areca cultivation is starting to become an attractive prospect in Indonesia as an effort to increase areca crop yields. To increase the yields of areca plants, it is necessary to know the disease of the areca plants to prevent crop failure. Often that areca is attacked by pests and diseases that attack this plant. Apart from being influenced by natural factors, disease of the areca plant often make the areca plant unable to grow ideally and even cause the areca plant to die. The main diseases that attack areca plant are yellow leaf spot, red rust, and yellow leaf disease. Identification of disease in areca plants is one of the important activities that must be carried to control the disease. This research aims to segment the image of areca palm leaf to determine the types of diseases that attack the leaf of areca palm plants using digital image processing with the active control method. Research method. Data collection. Image data on areca plant were taken from the areca palm seedling aged between 1 to 2 years with a size of 1 to 2 meters. The image of the areca palm leaves is taken using a smartphone. The data used was 172 areca leaf measuring 1,200 by 1,600 pixels. Consists of 40 normal leaf images, 40 red rust disease leaf images, 44 yellow spot disease leaf images, and 48 yellow leaf disease image data. You can see on the slide, areca leaf image data. A is normal leaf image, B is yellow leaf spot, and C red rust, and D yellow leaf disease. Stats of image segmentation of areca palm plant leaf. The stats of image segmentation of areca palm plant leaf is to process is the pre-processing and segmentation. Pre-processing is to image acquisition, resize, Gaussian blur, and mean shift. And segmentation is whose saturation value has with color segmentation and active contour to segmentation the areca palm plant leaf. First image acquisition is use smartphone. 226 data were taken, consists of 172 training data and 54 test data. The test data is used for the next step, which is a classification. Resize is used in this study is to resize the image for 100 by 200 pixels. After the digital image data has been resized, the results of the resizing will be processed again to the next pre-processing step. The next processing step is Gaussian blur. The Gaussian blur technique will reduce the noise in the image data of areca leaf disease so that the image data will be smooth and can recognize area infected with the disease and will be easily detected by the system in recognizing the criteria for the type of disease in the areca leaf image data. And the last stage of pre-processing is mean shift filtering. The resulting Gaussian blur image will be processed using the mean shift filtering technique. The purpose of using the mean shift filtering method is to produce sharp digital image or image by eliminating netting noise or noise and adding details that are lost after using the Gaussian blur method so that the quality of the result Reka leaf image is better and sharper and detail in this image. Reka plan loss due to the Gaussian blur method can be recovered. And next we go to the segmentation step. The first segmentation is color segmentation, and we use hue, saturation, and value or HSV. In this segmentation steps, the mean shift filtering result of the image are segmented by using the HSV color space. At this stage, the image conversion from RGB to HSV color space is performed. This method was carried with the aim of facilitating the segmentation process in separate area in the Reka leaf image because the HSV color space is more flexible than image with the RGB color format. At the time of separating the image in this stage, masking is also carried on the image of Reka plant leaf. Masking is used to separate the color of the Reka leaf image by removing unnecessary colors in the Reka leaf image so that the result of masking is the Reka leaf image in the form of a binary image will be converted into the RGB color space to produce a better leaf image. Focus on the Reka impact with the disease. This can help the segmentation process to be more accurate. The last at this segmentation stage is using the active contour method will describe the model of the contour in the image area of Reka leaf image. The HSV color detection result assist in the active contour segmentation process to mark disease infected areas in Reka leaf disease image. Result and discussion. The segmentation of leaf images are produced on a computer with specification using an AMD Ryzen 5 processor with a Radeon graphics card with a processing time for its image ranging from 12 to 17 seconds. You can see on slide the result for the segmentation. You can see in Pic 2, A, image in A is segment equate image acquisition, and B is image from resize image. C, image from Gaussian blur image. D, mean shift filtering result image. E, HSV result image. F, HSV masking image. G, result from image HSV masking. H, active contour image result. As can be seen from the segmentation result image above, the active contour method has succeeded in marking the selected area from the HSV image. Conclusion. Disease identification of Reka leaf image is carried in several steps. The first stage is data collection, the second stage is the segmentation process on a Reka leaf image, and the third stage is data classification to detect the type of disease on Reka plant leaves. This research consists of stage 1 and stage 2, so that this research can be continued to the next stage, namely classification. The first stage is data collection. The data used in this study amount the 172 Reka leaf measuring 1,200 by 1,600 pixels consists of the 40 normal leaf image, 40 red rust disease leaf image, 44 yellow leaf disease leaf image, yellow spot disease leaf image, and 48 yellow leaf disease image data. The segmentation after data acquisition is resized by taking the data size of 100 by 200 pixels. After resizing, the next step is to reduce image noise using Gaussian blur. The next step is to improve the quality of the result Reka leaf image to be better and sharper and In the image of Eureka research, dust are lost due to the Gaussian norm that can be recovered using mean-safe filtering. The result from mean-safe filtering is segmented by color using HSP and then marked in certain areas using active contour segmentation. For the next research, it can be continued to the classification step so that the type of disease can be determined. Acknowledgement. Thank you to Universitas Islam Riau to support and funding this research. Thank you, everyone.
So anyone have any question for the presenter 9, Ms. Rio? Then you can leave the comment here. So we will forward that comment to the respective presenter. Thank you, everyone. So presenter number 10. Presenter number 10, paper ID is 9973. IoT-based smartphones, a survey of technologies, service, and challenges. Presenter number 10. So you can start your presentation. Thank you.
Is my slide visible?
Yeah, it's like this.
Thank you, everyone. Good afternoon. I'm Paul Nelson, Lado Nelson Wanifrancio. I'm going to present a paper based on the a review on smart house technology, like mostly like a focus on communication technology and the services and the challenges that have been faced like on a smart houses. Okay, like, yeah, I have the key term here, like we have IoT, which is like Internet of Things. We have like smart house, and we have wireless technology, and we have like home automation and appliance control, and we have cloud computing and healthcare, smart healthcare. Okay, on the introduction, like, first of all, like we have to know what is IoT. IoT, like, it is like a system that allowed like devices to be connected and remotely like monitor through the internet. Like with the remarkable increase like in interconnected devices nowadays, like it increased like the innovative application and the services, like transforming like our daily life to be easy, and like it make like our business operation to go easy. And like this, the smart house, it's refer like to a convenience house, like a house like you set it up in a way like the appliance inside the house and the devices inside the house will be automatically controlled and like can be controlled from anywhere with just an internet. You've been connected to internet using your phone or any like network device you can control. And like on the smart house system, it's composed of integrated like devices, yeah, like the devices inside the house, which is like we have like the aircon, we have the TV, like they are all like integrated together. Like they work automatically, like either you use your phone to control it, or like you can set up a way like it can work on itself alone based on the instruction you set. Okay, like the objective of this paper is like, it's just like we provide an overview of a smart home architecture and the technologies and the services and the challenges associated with the IoT-based smart house. And also like we examine the different communication technology used in smart home house and we compare them and we explore the services enabled by like IoT in smart houses. And also we address like the challenges related to security and privacy and interoperability and resources constraints and the cost. Like by that, like we analyze the challenges. So like this survey, like we only like we offer for you like only like the insight in the advancement and the future direction of the smart house field. Okay, like if you talk of the architecture, it is like the way like how we connect the things, like how we connect the things within the smart house. And like the architecture, it's always like it vary based on the requirement and the technology you use and the level of complexity like desire. And yeah, like on the architecture of the smart house, like there are some influence, like it's been employed by like how like the device interact with each other, how like one smart device within the house, like for example, the TV and the speaker, how they interact with each other. And also like how and where like the sensor and the appliance, like where they store their data, where the data, like the data being collected from the house. Like for example, like you may have like this one, temperature sensor, like it has to detect like if the room is warm, then like it has to collect data and like, yeah, this is one of the influence, like where like the data being stored. And also like how they extract the data and how they process the data. And also like the way like as human, how did we like how we interact with the device itself, how we control it. So like yeah, this figure, like it is the overview like of the layers, like the layers being used, like the architecture layers used in smart home. Like the layers, we have 4 layers. We have like the device layer. The device layer, like it's mainly like it is composed of the devices, like these are the devices like within the house, like being installed inside the house, such as like we have like AC, we have like appliance, we have fan, we have the speaker, and we have light. Yeah, like it's all those things like within the house. And like those devices, most of it, like they have sensor, like to sense and detect the changes within the home environment. And like they perform like certain action, like based on the instruction like from the controller, or like you set it, like you set it on the device itself, like to perform. And like in communication layer, the communication layer, like it's the layer, like it's responsible for communication between the smart devices, like in the device layer, like the communication, if you communication between like the speaker and TV or camera and like the outside environment, like the sensor, like all of them, they have sensor. Then like with the sensor, it is where like, yeah, that it can communicate if there is something, then like it has to perform a certain. And like in the communication layer, like we usually have like communication, like this one, communication protocol. The communication protocol, like it like it is the one like controlling the communication. And then we come to control layer. The control layer, it is like it is the layer which include like which control like the communication and the devices. It is like the gateway. The gateway, like install, like you install a gateway inside the house. It communicate, like it take the communication like to the server layer, which is like take it to cloud. And like if you come to this service layer, like this is the interface layer through which like the user can interact with the devices at home. It can be like a mobile, they can access it using mobile or like web-based. And the communication, like yeah, communication play critical role like in smart house, which is like responsible for connectivity and data exchange between various components. And like communication mostly like there are two types of communication. Either it will be wire or wireless communication. Like wire communication, it is the involvement of where you connect cabling, connect your devices using cable. Wireless, like you can connect your device mostly using wireless. And like in the current technology right now, most of the smart houses, they prefer wireless connectivity because like it is not expensive, it is easier to access, and it is flexible. So like these are the some of the wireless technology being used in smart houses. One of which we have like RFID, which is radio frequency identifier. Like this radio frequency identifier, like it uses electromagnetic field. It uses electromagnetic field like to detect and track like the tags attached to an object. Like it mostly has like two parts. Like it has two parts, which is like we have like the RFID tag and we have like the RFID reader. So like the object will have like the tag and you will have the reader. When you bring the tag next to the reader, it will detect. Like RFID can be integrated into IoT-based smart home system. Like it enable various application and enhance automation and security, like to be convenience. And also RFID, like it is low cost and usable, and it provides like reliable and provide reliable form of automation identification, which make it cost effective technology to use. Like for example, you may have a fridge and you will have like the RFID reader within the fridge. It will like, you can come and scan the tag. It will show you like all the items inside the fridge, which has like a tag. It will show you like how many items are inside your fridge. It lists the names of the item, the ingredients, like how they be made, and the expired date. And mostly in the developed country, like you can see, like it's been used like in convenience store. They use like the RFID like to process the items inside the convenience store and like in big stores also. The second technology is Bluetooth. Bluetooth like is mostly used. It is used for wireless communication, like for a within short range, like to exchange data between devices in a short range. We use Bluetooth, and like Bluetooth, like it is easy, like because of the short range features and easy of use, and like it provide like low power consumption. It make it an ideal like choice, like most of the people use it to go in term of communication within short range.
Mr. Nelson, can you,
Yeah,
your time is almost over, so can you go a bit fast, please?
Okay. Okay, we have like Zigbee. Zigbee is also one of the communication technology, and we have like Z-Wave. Like it's also like perform similar activity as Bluetooth, and we have Wi-Fi. In Wi-Fi, like you connect your devices using wireless connection, and we have like Thread. Like Thread, like it provide like a mesh topology, like they connect the devices are all connected together, and they act at the same time like as a server. Also, we have Ocean. It's one of the technology being used. Okay, this table, like it is a comparison of the technology based like on the date, the day of release and the frequency and the data rate and the power consumption. Because of time, I don't think I can go through all of this table. Okay, like in home automation, like we have like services. The services being offered like services through the smart houses. We have like 3 services mostly on my paper. One of which is the lighting. Yeah, it's the lighting like giving the user or the householder like an opportunity to control the light using mobile phone, or like you said it there. You can like using smart lighting. It reduce like the power consumption, and it will also reduce like human intervention. And sorry. Okay. Also, like we have like home automation control. Yeah, you can control your devices like using your phone and or like using web server. And on term of remote monitoring, yeah, like you can, and smart alarm, like you can access, like you can get an alarm in case there is something going on in your house. For example, like if someone try to access your house while you are not there, it will show you notification so that like you can take an action toward that case. And like, yeah, there are challenges being faced with smart home, which is like mostly like the privacy and interoperability. And we have like resources constraint, and we have like the cost. So in the conclusion, yeah, like based on the, like there is a high increase in IoT devices and adoption of home automation, like it offer numerous opportunity, like in enhancing like convenience, effective and cost saving in our daily life. And with home automation, like it offer like the potential to automatic tests, like provide remote control and monitoring capabilities, and offer like various services such as security, healthcare, and childcare, and like elder age care. And also like in smart buildings, like it contribute to low operating costs through energy optimization and integration of like building infrastructure system. And on the challenges, we have the challenges. It ensure like the successful like way, like how we should implement the smart technologies. And thank you.
Thank you, Mr. Nelson. Thank you for your amazing work and amazing presentation. So any of the participants have any question for Mr. Nelson? Any of the participants have any question for Mr. Nelson? Okay, Mr. Nelson, maybe they do not have any question, but I have one question for you. So you mentioned about the couple of technologies. So do you implement either in software or in prototype case? Did you implement any of those technologies?
No, Professor, I just made the review. The review of it, just I go through like some research papers, and I just make like a general review.
Okay.
I didn't implement
In future you are going to apply those things, am I right?
Yeah, sure.
Okay. Thank you very much, Mr. Nelson. Thanks a lot.
Thank you, sir.
You can stop sharing your slide. Thank you. So is presenter 1 is here. Session 2, presenter 1, human activity tracking using mobile sensor data and optimized LSTM. Miss, you are here. May I have your name, please?
T. Geeta, sir.
So can I call you Geeta?
Yes, sir. Sure, sir.
Yeah, thank you, Miss. So Miss Geeta, so your session is not now. Your session is around 11 a.m. in the morning. So somehow you miss. It's okay, no problem. So now you can present, okay?
Okay, sir. Thank you, sir. Is it visible, sir?
Yeah, it's visible.
Good morning, sir. So
Miss
my
Kita,
project.
can you please do one thing, please? You check your presentation file. There is upper part. There is a option called enable editing. So can you click that one? It will make your size of your slide bigger. Yeah.
Is it okay, sir?
Yeah. Thank you.
Okay, sir.
So please go ahead.
Name of our project is Human Activity Tracking using mobile sensor data and an optimized LSTM. So this project is guided by Sarvani Anandarao madam, and these are my co-teammates. So here are the contents: abstract, introduction, existing system, proposed system, diagrams, flow of proposed system, methodology, and result and conclusion. So this is the research which we have searched
I'm sorry,
about
Miss
our
Gita, I
project.
need to interrupt you. I'm sorry. So I think you means you do not need that enable editing. Okay, so the slides that come in a very short of. So we're having problem. You
Is
cannot
it
see.
okay now?
Yeah, now
I will
change
once
the option
again.
enable editing, then share.
Is it okay now, sir?
Just wait. Yeah, this time is okay. Thank you very much. Thanks a lot. Please continue.
Okay,
I'm sorry
sir.
for interruption.
No problem, sir. So this is the literature survey. So we have searched about our project and we have gathered the data. So here is the abstract of our project. So nowadays, mostly smartphones plays a major role in our daily life. Even the small kids are using the smartphone. Even no one is staying without the smartphone nowadays within a hour or 2 hours also. So this is the main reason for taking of this project. So smartphones are used for human activity recognition. So here, human activity recognition system can track the human behavior and real-time monitoring system. So we have proposed this for identifying the human activity in any of the dynamic situations. So in the existing system, they have used some algorithms of ML like KNN, LSTM, SPN, etc. on different data sets, and they have some good accuracy level. So for getting better accuracy, we have compared this project to the existing system, and we have used some algorithms with the combination of LSTM, with the combination of the optimized algorithms named AdaGrade, AdaMax, and HGD. So by applying these optimization algorithms, we have got some better accuracy results. So this project can also be used in healthcare recommendations for the prisoners in smartwatches also. So this is about the abstract. Coming to the introduction, as I said before, they have used some algorithms of ML like KNN, decision tree, SVM, etc. Here we have used some optimization algorithms. So based on the mobile phone movement of the mobile phone, so it gives as the output like whether the user is standing or sitting or jogging, etc. Whatever the activity he is done, that activity will be given us out from the speaker of the mobile phone, and also displays on the screen that whether the user is sitting, jogging, or etc. So it is about the introduction. As coming to the existing system, as I said before, they have used the algorithms like KNN, Navi-based, LSTM, and this is the brief explanation about them. So as coming to the proposed system, so this is this general view of the diagram. So here we are taking the mobile phone as the main source, and from the mobile phone we are considering some activity data set. So whatever the activity that is used by the user, whether he's sitting, jogging, standing, etc. So here some that mobile phone consists of the sensor. So it consists of some services, it consists of the hardware part and wireless communication like that. So these are the algorithms which we have used with the combination of the LSTM. So they have used the LSTM, but why we have used these three algorithms with the combination of the LSTM is, so RNN is the updated version of the LSTM. It stores only the current activities. It does not remember whatever the previous activities it is done. So LSTM stores the whatever the current activities and also the completed activities in any of the dynamic situation. So the main problem with this is, so it uses the random weights, which leads to the local optima. That means whenever two random weights are same, it uh, it confuses whether what to use, what to select. So that's why we have used these three algorithms: ADA grade, ADA max, and HGD. It's coming to the ADA grade. So this is an optimizer that has the parameter specific learning that can be adjusted based on how frequently a parameter is changed during the training. It also updates whatever the parameter that receives. So this is one of the optimization technique. As coming to the ADAMAX, it is the first order gradient based optimization techniques. So this reduces the local optima. As coming to the HGD, whatever the optimal parameter configuration is found. So if there are any errors in the network, it finds the errors and modifies, does small adjustments in it, and does the network correctly. So these are the UML diagrams of this project. So here, so HMR tool, it firstly monitors the mobile, whatever data it is there. So it senses through the sensor. And then whatever the data it is necessary, it preprocesses the data and extracts. So after whatever the data it is necessary, it trains and tests the data. So and then it predicts whether the user is based on the activity, it predicts whether the user is standing or sitting, etc. And then it updates the result through the speaker. All this can be viewed by the, so this result can be viewed by the user. So as coming to the class diagram, so here user is the class name. So and the attributes of the user like user ID, mobile number, password, etc. And the methods like walking, running, sleeping, sitting, etc. And here are some, we have mentioned some class names and its attributes and methods. So this is the activity diagram. So here user, whatever the activities it is done by the user or mentioned here, like activities done by the user, whatever the input data is given to the system, and output comes through by the speaker. Here HMR tool, whatever the HMR tool does, it shows or whether like whatever the data it, and like whatever the data it senses from the sensor, whatever the data it is necessary, it extracts, and then it selects, and then it trains and tests and gives the output to the user. So this is the flow of the proposed system. It's in just normal diagram. As I said before, whatever like it senses that all, it is represented in a diagrammatic format. So same, it is mentioned as a methodology in a flowchart diagram. Here the user does the activity, whatever the raw data it is present here. So it senses whatever the data it is necessary, it senses, and then it collects whatever the data, raw data it is necessary, it collects and extracts, and then here it performs the classification models, and then it's whatever from that it predicts, and then that predicted activity will be sent to the testing. So it is about this diagram. So some data sets like this. Here is the result of our project human activity performance. So like this. So this output will be shown based on the movement of the mobile phone, whether the user is standing, then here this blue color pop-up will be on standing, or if the and so that pop-up will be done by the accuracy. So based on the accuracy, this probability will increase. So which probability is higher, then that probability will be highlighted, whether the user is standing, like that. So this is the graph. So here some it shows like green color is walking, like red color is standing, like that. Based on that movement of the mobile phone, based on the probability of that, which gives the higher accuracy. So like that, this graph will be shown. Here are the performance analysis. We have calculated accuracy, time, complexity, and all. As coming to the conclusion, so so this project can be mostly used in which will be helpful for the prisoners. It can also be used in the smartwatches healthcare recommendations. So as we know, in smartwatches, it can track the activity and also notify to them. So here we have used the output comes out through the speaker. Why it is? Because to alert the person. As if we consider the prisoners, it can also shows that whether what the prisoner is doing, whether he is standing or sitting, what he is doing. So if he is running outside the prison, then it can notify these people. It can give an alert message to these people that this prisoner is going out. So it can be helpful to that, and can also be helpful in the healthcare recommendations. That's it, sir. Thank you, sir.
Thank you very much, Ms. Gita, for your amazing presentation and work. So
you, sir.
any of the participants have any question to Ms. Gita? Any of the participants have any question to Ms. Gita? Okay, Ms. Gita, they do not have any question, but I have some question. So can you please go to your model slides? Sorry.
Methodology, sir.
No, please go down a bit more. Yeah, here, slide number 40, please.
Yeah, sir.
Which types of pre-processing means image? Which types of pre-processing you use for after sensing the data? So which types of pre-processing you did?
Pardon me, sir. I cannot understand it.
Means here you say that after you will check the motion of the movement of the person, no? So
Yes, sir.
you sense those movements of the person using mobile phone or a smartwatch, am I right? So
Yes, sir.
after that, you told that you did some pre-processing. So I'm just asking which types of pre-processing you applied.
So here we will given some data set, sir. So it consists of whether that person, I mean, it consists of sitting, jogging, like that, sir. So from that, it will sense and it will extract. It will apply here some classification algorithms, whatever the algorithms it is necessary, and then it does, sir.
What types of algorithm? That's what I'm asking. What types of algorithm you applied?
Like SVM, and we have applied some optimization algorithms, no, sir. So this.
No, I'm talking about pre-processing. Okay, I understand. So you use not the mobile phone, you use the data set, am I right?
Yes, sir.
Okay, okay, understand. So which types of feature extraction you did in the next phase after sensing? You mentioned feature extraction. Which types
Yes,
of
sir.
feature extraction you did? So just curious about that.
Whatever the data it is necessary.
Okay. Okay, understand. No problem. Okay, thank you, Ms. Gita. Thanks, thank you very much for
Thank
your
you, sir.
presentation. Thanks a lot.
Thank you, sir.
Yeah, have a nice day. Bye.
Thank you, sir.
So, presenter number 4, paper ID 7961, paper name hybrid classifier for software defect prediction by using filter-based feature selection technique is present here. Presenter number 4, paper ID 7961, hybrid classifier for software defect prediction by using filter-based feature selection technique is here. Okay, presenter 5, paper ID 9717. Evaluate paper name, evaluating the effectiveness of deep learning algorithms, a comparative study. Is presenter number 5 is here. Is presenter number 5 is here. Paper ID 9717. Okay, understand. Not yet. So unfortunately, our presenter number 11, as you know, our Muslim colleagues is having Eid today. So the presenter number 11, they are from Indonesia, so they cannot join. So they send us a video file. So we will play that video. Let's have seen their presentation, video presentation.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. In this video, to present my research entitled The Promotion of Real Malay Traditional Food Using Augmented Reality Based on Android. First, I will tell you about traditional food because I came from Riau Province, Indonesia. So my research is traditional food in Riau Province, Indonesia.
Miss Saifiriani, are you there, Miss? Hello. Miss Saifiriani. I'm going to continue the video.
Traditional foods are foods and dishes that are passed on through generations or which have been consumed for many generations. Riau Province is one of Indonesia's many provinces with cultural diversity, and traditional cuisine is one of its cultures. Traditional food from Riau comes in a variety forms, depends on the state of the neighborhood and habit from society. But the problems are, first, there is a chance that traditional foods will become obsolete because of their great diversity. Second, not every person can make traditional food. Even traditional food can make professionals are less skilled. Third, among the younger generations, fast food, Western food, and foreign food better known than traditional food. Fourth, the main concern of the author, traditional food will disappear if there is no one care or aware and shows no interest in traditional food. Because of these problems, the impact is there is no doubt that traditional foods will vanish from the population because no one cares and is aware of them, has no interest in them, and lacks literacy and knowledge about them. So, author found a solution. How about to promote Riau's traditional food? Because now is the age of technology, author will promote traditional food using an Android application. In this research, also joined IT lecturer. For the methodology, we use multimedia development life cycle or MDLC and analysis descriptive. As for we know, analysis descriptive methodology is an approach to research that aims to describe and analyze phenomena or variables systematically and detailed. Result from this methodology. First, the young generations prefer use technology rather than books to learn something new because technology can take them to another level learning something. Second, the young generations don't know about traditional food because most of them don't get any information about traditional food from parents or the community around them. Third, there are variations in the preparation of traditional dishes. There's nothing wrong with variations, but too much variations can eliminate the characteristic and values of the traditional food itself. Fourth, many members of the community do not know how to prepare traditional dishes because traditional food itself doesn't serve daily. Many from traditional food serve at occasional events only, like wedding, Eid al-Fitri, and Eid al-Adha. Plus, lack of documentation from traditional food itself, so only certain people can make traditional food. From the result of analysis descriptive methodology, author use this data as a foundation for next methodology, multimedia development life cycle. MDLC has 6 stages. 1. Concept. 2. Design. 3. Material collecting. 4. Assembly. 5. Testing. 6. Distribution. Concept. Concept is how the application look alike. Application title, Riau's traditional food. The purpose of the application to provide knowledge and education to the public about Riau traditional food. Audience, the general public. Image, an object that was created using Blender and implemented using Unity. Application type, augmented reality application. Design. Design is flow from the application. From these designs, the application has 4 menus, which are traditional food, ingredients, how to make, and history. Every menu will lead to animation, then to side menus, language for Indonesian or English, and voice to turn on and off the voice. Material collecting. This stage, author collects material that relate in traditional food. Bolu berendam. Bolu berendam is a typical dish from Indragiri Hulu. gold yellow color, and serve immersed in sugar syrup. Bolu berendam is the preferred food and Bolu berendam is the preferred food of monarchs. This cuisine is only served on special occasions such as wedding or Eid al-Fitri and Eid al-Adha. Bolu Komojo. Bolu Komojo is a traditional dish from Siak and has been fashioned to resemble a Cambodia flower. Bolu Komojo uses pandan leaves as main ingredients. This cuisine only served at specific occasions like Eid al-Fitri and Eid al-Adha. Sempolet. Sempolet is a classic dish from Meranti. It tastes savory and spicy. Sempolet uses sago flour as main ingredients, combined with vern, spinach, shrimp, and anchovies. Koke asam durian. Koke asam durian is a traditional dish from Rokan Hulu, more precisely Pasir Pengarayan. Koke asam durian is a spicy curry made with fermented durian, petai, and anchovies. Kacang pukul. Kacang pukul is a traditional dish from Rokan Hilir, as it name kacang or peanut. Kacang pukul uses peanut as main ingredients. Kacang pukul is a traditional snack for generations. Nowadays, kacang pukul become a popular gift from Rokan Hilir. Assembly. This stage is where authors assemble all the materials. This is main menu from Riau's regions. There are 12 regions in Riau, and each region has different traditional food. Animation page. This page shows an animation from one of the traditional food, which is kacang pukul. This page not only shows kacang pukul, but shows from ingredients, how to make, and what it is look like. Testing. In the stage, author tests the application to see whether this application already for community needs or not. Author uses questionnaire, and there are 7 questions. The result is 66% said this application excellence, 31% good, and only 3% said poorly. Distribution. After testing, author step into final stage from MDLC, which is distribution. As you can see, the table shows the assessment from the application. It gets 90.85% score for this application. It means this application is accepted in public. Result from research. The assessment result can prove a real traditional food application can help people to know, learn, and understand real traditional food by the value of 90.85%. Conclusions. 66% of people love to use real traditional food applications. This application reached 90.85%. The application can become an alternative media or learning media. That's for my presentation. Thank you for the opportunity you gave to me. For the final word, I'm very sorry for my mistakes. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Thank you for the presentation. So if anyone have any question for presenter number 11, so you can send your question in the chat. We will forward that question to the respective presenter. So just last announcement, just last time calling. So presenter number 4, paper ID 7961, paper name hybrid classifier for software defect prediction by using filter-based feature selection technique is present. Presenter number 4, paper ID 7961 is present or not? Okay. Presenter 5, paper ID 9717, evaluating the effectiveness of deep learning algorithms for comparative study is present, is here. Okay, thank you. Okay.
Taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Thank you for the presentation. So if anyone have any question for presenter number 11, so you can send your question in the chat. We will forward that question to the respective presenter. So just last announcement, just last time calling. So presenter number 4, paper ID 7961, paper name hybrid classifier for software defect prediction by using filter-based feature selection technique is present. Presenter number 4, paper ID 7961 is present or not? Okay. Presenter 5, paper ID 9717, evaluating the effectiveness of deep learning algorithms for comparative study is present, is here. Okay, thank you.
Excuse me.
Yes, please.
I'm the presenter too. Paper ID is 8583.
Oh, so I was calling for you for a long time. Okay, so
Okay.
so you can present your paper. Okay.
Okay.
So mostly we give 15 minutes to the presenter, but as you it's almost delayed, so please go through a bit fast. Okay.
Okay, sure.
Okay. Thank you very much.
Are you able to see?
Yeah, I can. It's coming. Yeah, I can see now. Thank you.
Okay, thank you. So the topic of presentation in my paper is speech to sign language translation using CNN. I'm the author, and my co-authors are Mr. Jitendra Singh, Mrs. Archana Singh, Mr. Soumya Ranjan, Mr. Raghavendra Kumar. The objective of my paper is to build a technology which converts speech to sign language, and the people who are facing from deaf or hard hearing disability can have a technology so that they can converse with anybody around. If you know, generally, if a person is having a disability of deaf or being hard of hearing, they need a second person around who can translate their language to a normal other language like English, Hindi, or some other one. But my earlier research paper was on recognition of speech, sign language to speech, and this is speech to sign language. So my aim was to merge both of them and make some technology so that they can communicate with anybody around without any second person. So as I've said, it is about speech to sign language translation using AI. That aims to develop algorithm that can continuously translate spoken language into sign. And the data set I have used is American Sign Language, which includes 8, wow, bed, go, happy, and multiple other words. So in total, there are 31 different words. And the libraries and modules used are Keras, Matplot, NumPy, Pandas, and SciPy. So a spectrogram is used to extract relevant information such as frequency, content, and intensity of different sounds component. And by representing visual frequency content, all the images are passed to a convolutional neural network and thus followed by a prediction. Now, we know that convolutional neural network is used for image processing. So whenever it is about audio classification, people go for RNN over convolutional neural network. But as I have told you, I have already published a paper on recognition of sign language and converting into speech. Over there, I have used CNN model. So I wanted to, it is an extension of that paper. So I wanted to use the same model. That's why for audio classification, I used in convolutional neural network. And how it works for audio classification. What we do is we convert the audio streams into spectrogram, which provides a visual representation of spectrums of frequency over time, and classifying the spectrograms using convolutional neural network. They are the following procedures. First, data is pre-processed, then preparation of each data. Then there is a model architecture, training, validation, testing, and final is the prediction. So the steps I have just introduced you were data collection. They were, as I've told you, for data collection, it is American Sign recorded from the source was Kaggle. It includes 16,536 audio samples, which is organized in 31 categories. The second step was pre-processing. For pre-processing, I have used a squeeze function. So a squeeze function removes single dimensionality audios, and then a waveform is visualized for each of the audio, which is passed to a spectrogram function. Here is the visualization of waveform and spectrogram for a single word 3. So the model used was convolutional neural network. So for the processing of audio data, apart from the images, specifically spectrogram, frequency context of the audio is visualized over the time. So there are multiple layers such as convolutional, pooling, and fully connected layer. So the model has 2 convolutional layer followed by a max pooling layer. And then there is a flattened layer to convert all the multidimensional layers into a single dimensional. The model is evaluated using confusion matrix, which is used to forecast and display real classification model performance. So all the data by data, if you can see over here, this is the loss and accuracy. The results are whenever you execute the program, you will find the first block as record press to stop. So it starts automatically recording. So whenever you want to stop, you have to click on this press to stop button. After that, the recording gets saved for a temporary cloud storage as the name of audio.wav. And if you want to replay it, you can replay it. It is for replaying it, this is a temporary thing, just to verify the audio is correct or not. After that, the same pre-processing is done. The audio is passed to the same squeeze function. Then the waveform is visualized, and that waveform is passed to the spectrogram. And through the model of CNN, it is the prediction is evaluated. If you can see, the audio was sent, which was this one. It was about 7. So the prediction is 7. It gave a text and a image aside. In the future, I am planning to expand the data set, improve the user interface, and incorporate different languages. I have also written another paper which I am going to publish, where I have added language switcher. There are 3 languages: English, and English, Turkish, and Indonesian. They're the 3 languages. So the person who's using it can choose the preferred language first and move on with the functionality. Even I am planning to add more data set to the existing one so that it is more efficient. And even if I need to change the model for more accuracy, for good performance, I will try for that. Thank you.
Thank you very much, Ms. Yusra Khan. Yeah, thank you very much. Thank you for your amazing work. So we will thanks you for your amazing work and presentation. Okay, and thanks for participating in the Smart Cyber 2023. Okay, have a nice day. Okay. So with this one, we will finish the Smart Cyber conference session here. Thanks to all the participants. Thank you very much.
Thank you. Bye-bye.
Thank you. Bye-bye.